Hello everyone, I welcome you all to this lecture. In this lecture, we are going to discuss the functionality of physical layers. So let's look at all the functionality of physical layer one by one. The very first thing which physical layer does, it decides the transmission mode. And in the previous lecture, I have elaborated. Generally, there are three modes: simplex, half duplex, and full duplex. Right? So in simplex, only one directional communication is possible. In half duplex, both the direction, the data can be sent, but at a time only one direction will be active. In full duplex, data can be sent at any point in time in any of the direction. So in full duplex, I have given you the example, let's say telephone or phone. Half duplex like walkie-talkie, and simplex like you consider we have remote control and we control the television. So only remote send the signal to the television, television doesn't send it back. Right. The next important function of the physical layer is the transmission media. So it also deals with the transmission media. And I have already told you in the previous class, there are two types of media, guided and unguided. In guided media, there are twisted pairs, coaxial cables, optical fiber, or you can say fiber optics. In unguided media, there are different types of signals we use. So we use radio waves or microwaves or infrared waves. Generally, the media is wireless here. So this uses wireless media, air or atmosphere work to flow these signals. Now, physical air also decides the data rate. So in order to decide the data rate, the physical layer first sends the channel. If channel is noiseless, then the capacity of the channel is or can be calculated by Nyquist bitrate. So you can remember Nyquist bitrate formula. So I'm highlighting here. Nyquist bitrate is somehow given like this by Nyquist. So C is the channel capacity here, B is the bandwidth, and L is the level of whatever the number of levels are there in the signal. So if we have binary signal, it has two levels. So let's say if we are having a signal like this, it will be the 0 or 1. It has only two levels, right? Like this. There may be some signals which may have more than two levels. So the value of L will be more than 2 in that case. Like if a signal is like this, it is having let's say 0, then let's say 1, then it comes to 0, but it goes in negative direction also, let's say. It is having let's say -1 also. So it goes like this, it comes to 0 level, then 0, then let's say maybe it is going up, then. So in this signal, you can say there are three levels. So L is equal to 3 in this, there is a negative level also, right? So with the help of this formula, we can calculate the channel capacity if channel is noiseless. But if channel is noisy, we have to use the channel capacity formula to calculate the capacity of the channel. So this is the formula. And if your channel is noisy, in the question, signal to noise ratio will be given. So S divided by N gives you signal to noise ratio. And generally, this signal to noise ratio will be given in decibel. So dB or B. So we consider as decibels or bells as a unit, right? So these bells or decibels means bells generally represent like in 10 to the power. So we consider log of 10 signal to noise ratio. This we consider as decibels. And what is deci? Deci means you multiply this thing with 10 and you will get the decibels. Okay. So when we solve the questions, then you will get to know that how we will utilize this. So the important function of the physical layer is it decide the data rate of the channel. Then it also works for synchronization. So it utilizes a clock, and this clock helps the physical layer to synchronize the transmission of data. So physical layer can control the speed of bit transfer from sender's end. Okay, as per this situation. Now the next function of the physical layer, it also decide the line configuration. There are different types of lines. So there is point-to-point connection, multi-point connections. So in topologies, you must be aware about there is a mesh topology, bus topology, ring topology. In mesh topology, every node we connect with every other node. So let's say if there are 5 nodes like this, the connection, every node will have connection with every other node like this, right? So this is mesh topology and it has point-to-point connection, point-to-point, direct connection. So every pair will have one active channel. But in multi-point line configuration, let's say you consider a bus topology. So in bus topology, we have a backbone network or backbone line. And with that line only, every computer or node will be connected, right? So like this is a channel or a line which is having multi-point because this one single line, multiple devices are being connected. So this is one of the very important functionality of the physical layer. Then physical layer also decide the topology. So there are mesh, star, bus, ring, tree, and hybrid kind of topologies also. Mesh look like this. Every node is connected with every other node. It uses point-to-point connection. So in this, if I talk about quickly few of the properties like the number of cables or the requirement of cable will increase because every node need to be connected with every other node. But the communication security will be enhanced because once this computer will send some data to this computer, there is a separate dedicated channel, right? So the communication will be very secure. But the cost of setup of mesh topology will be high, right? So these are few of the things. And wiring will be complicated. So it is written like complicated wiring and the redundancy will be high. In case of star topology, there is a central hub. So this is a central hub. Hub is a physical layer device, you know that. So at one side, the data it will receive and it will, you can say, repeat the same signal on all the remaining ports. So it is connected with, there is a point-to-point connection between hub and the devices like computers. Okay. So it look like this. If hub goes down, everything will be down. But in mesh topology, if one link is down, it doesn't affect the network. It will keep on working. So it is fault tolerant also. But in star topology, there can be a single point failure. But in case one link is not working, so let's say this link goes down, it doesn't hamper the network. It is still working. It depends upon the central hub. If hub doesn't work, then the network will be down. Okay. Then bus topology. The bus topology is cheap as compared to the mesh topology. In terms of security, it provides less security as compared to the mesh topology. In this, one channel or one line will be used as a backbone. Okay, it works very well in small networks. So I have written here small networks. So bus topology works well in small networks. And generally in bus topologies, these two types of wires are used, 10 base 2 and 10 base 5. So you do understand these things. 10 means the bandwidth is 10 Mbps. So 10 Mbps bandwidth. And this base means baseband signals, baseband. And this 5 means the repeaters or signal amplification will be required after 500 meters. So in case 10 base 2, the repeaters will be required after 200 meters. So generally we use these cables in bus topologies. Require less cables, easy to remove or connect the devices. So if we want to remove a device or if you want to connect a device, it is not difficult to manage that and it is cost effective. There's a ring topology. So the nodes are connected in a kind of cycle or ring. There's a tree topology and there is a hybrid topology. So when we want to connect two different networks, one network may have some other topology, another network may have some other topology. So in that case, we need to manage a hybrid topology, right? So the next property of the physical layer is the transmission of signals. So physical layer also take care about the transmission of signals, or you can say it deals with line coding. So for line coding, there are different methods, but generally in GATE exam, they ask for covers. There are two types of encoding methods or coding methods, standard Manchester coding and differential Manchester coding. So in standard Manchester coding, if we want to represent 1, so it corresponds to a low to high transmission in the middle. So I guess I have discussed in the class earlier. So if there is a transaction like this is low level, and from low to high, if there is a transition like this will be represented as 1. 0 correspond to a high to low transmission. So if a transmission is happening high to low like this, then it will represent 0. So this will represent 0. This is normal standard Manchester encoding. Now in differential Manchester encoding, 0 is represented like transition both at the beginning of the bit period and in the middle of the bit period. So let's say if we are having bit period like this, if this is the bit period, okay, and if in the starting the 0 was coming, so let me change the pen color. If 0 is coming here, like if we want to represent the 0, then first here the level will be changed, okay, and then in the middle of the bit period again the level will be changed. So it is high to low again will become. So this will represent here 0, okay. But in case of 1, the transition only in the middle of the bit. So if 0 is coming and in this bit period, if it is 1, then this will come straight. So it will look like this. If this is the bit period, and in this bit period, if we want to represent 1, and earlier low is coming here, then this will not be changed. Low will be Here, low level will be maintained till the middle of the bit period, and then the transition will happen. So low to high it will convert like this. So this will represent 1. I hope differential Manchester is also clear to you. So these are the functions of physical layer. We will discuss few of the things in detail in coming lectures about the topologies, and we will solve the questions on line encoding also. So thank you everyone for connecting. I'm closing this lecture.